Good evening. Happy Friday night. It is actually a Friday night. I think it's sunny and beautiful out in New York City. I have been in a dark room all day, all week, in fact, watching ITP thesis presentations. Let me just say that my mind was blown many times over. And I just want to mention this before I do anything else, that if you go to itp.nyu.edu/thesis, you will come to this website, and I think somewhere from here, you'll be able to find videos of all of the thesis presentations. So you should check those out. All right, so my brain has melted a little bit out of this ear. I think there were about 100 presentations, probably. I don't know the exact number that I watched this week. Tuesday, Wednesday, Thursday, Friday, all day. They finished up about an hour ago, and then I ran up here. Like, I'm going to do a live stream this week somehow, some way. You might notice I have this weird microphone here because I couldn't find the other microphone, and this was being used, and then I got this one. So I don't know. Hopefully this works and isn't too weird looking. I feel like I should be putting my finger in this ear and singing. So that's one thing. The other thing I want, that's it. Morning. I think things work better for me in the morning when I live stream. So, is the quality looking okay for everybody? I'm getting on my dashboard here, stream status bad. All right. So here we are. I don't think this camera is on, is it? Wait, hold on. There we go. I want to do a dramatic reading of an email I received earlier this week. I don't know if anyone has asked you about this yet, but do you use the Canon 5D Mark IIIs for live streaming? And have you figured out a way to disable auto power off? We've tried installing Magic Lantern, but we still can't figure out how to keep it from sleeping on live view standby. Yeah, I don't know. So just I'm gonna tackle this problem someday. We're gonna figure it out. But for now, for today, still these cameras are going to shut off in 20 minutes. The other issue I'm having is that I need new lenses. These lenses, if you can believe this, in my glasses, were purchased in the year. Travel back in time to when you remember, I don't know, what was it? The Macarena was big? No, 2015. I think the Macarena was in the 90s. I can't remember 2015. These lenses are really old. My prescription actually hasn't changed. The frames changed. I kept buying the same frames. You know, when I had my bicycle accident last year, the frames broke, but the lenses remained intact. But recently, I keep noticing they're like these like scratches, and they're older. I got to get new lenses, but right now, my vision in this left eye isn't optimal, let's just say. So I've got this microphone here, and if I look out of this part of the lens, I can see you. So this is the way I'm going to be standing. So I'm in a bit of a crazy time of year. I'm hoping as things settle down and I move into the months of June and July that I will establish sort of a weekly schedule, diving into some exciting coding challenges that I have on the horizon, some tutorials that I would like to do around machine learning and Tensorflow.js and this new library called ML5 and all sorts of things. But I don't know, maybe this, I don't even know why I'm bothering to say this, because I'm probably just always going to be in this state of complete and total disrepair. Oh, the Macarena, yes. Miayemsumi says, now that you've referenced it, you have to do the Macarena. That's a good point. I can't play the song, the Macarena, because then I will get a copyright notification. Although sometimes it's worth it. On these live streams, I might as well just play all the music I want to play, and then get those copyright notifications, because sometimes it's worth it for. No. Hey, shoot. There must be some like a visual guide to doing the Macarena. I know the hand jive. This one, I know this one really well. Okay, is this a coding channel? I think it might be. It may or may not be. SB129 asks in the chat, have you ever thought of live streaming on Twitch? I have. I have thought about it many a time. In fact, I have live streamed on Twitch. But I live stream on YouTube now. I don't know what I'm doing at all. If somebody could come, maybe some like corporate overlord could buy the coding crate. That's a bad idea. I like being a sort of independent entity. Although I am, of course, the Google, all my stuff is all over the Google. There's not really a way around that right now. What was I saying? I just want somebody to tell me what to do. No, I'm live. Twitch is here. Actually, I do have something to talk about today. You know what? I'm going to save this till the end. I don't want to bore, or I don't want to emphasize this too much. But I did get something unlocked into my account today, which is YouTube sponsorships, which is like a Patreon thing built into YouTube. And so I'm going to talk. Maybe I'll talk about that at the end. Somebody remind me. I could sing it myself. Somebody is writing, you could sing it yourself. Twitch is doing a super low latency beta right now. Ooh, interesting. Twitch is only good for people in the US. I'm also being told. So this is all very useful information. So what is happening today? I would like to talk more about Tensorflow.js. Now let's see where we are. It would be so nice. It would be so nice. I have so many whiteboard markers because they go bad so quickly. I have 6 of them. I'm almost certain I can juggle 2 of these. Okay, so we've got 2. I'm pretty sure I could do a 3rd one. Yeah, that's pretty good. Yeah, it's not so bad. I don't think I can do 4. Not with these. I think if you gave me 4 beanbags, I might be able to get it. Okay. That didn't work. All right. So I have just so many of these, but these are not the good ones. The good one is over here. How's the sound, by the way? Is the sound okay? No. Let's see. This one's a good one. All right. So now I need an eraser, otherwise known as a paper towel. So I'm working through a set of tutorials about Tensorflow.js. I'm learning machine learning. That's learning machine learning. Where I got to so far in the playlist was up through this topic of memory management. Now let me just be clear again. These are not comprehensive. I'm kind of scratching the surface, glossing over things. I am not the creator of Tensorflow.js, an expert on it, none of that stuff. I'm trying to figure it out. One of the things that I'm really excited to talk about today is the Layers API, because the Layers API is what will allow us to actually start to build some machine learning projects. And my goal is ultimately to do a couple of things. What are some of my goals? I just want to go home and take a nap, watch some baseball. I'm kind of a baseball fan. I'm kind of getting excited about doing some machine learning project with baseball data. But if you have some ideas about that, let me know. But anyway, I just don't know if that's really going to appeal. I mean, I don't know if that's going to. Okay, I didn't mean to talk about that right now. Let's just roll back in time and erase that. All right. There's a library being developed at ITP called ML5. ML5 is a high-level library for machine learning, and it's built on top of Tensorflow.js. So my goal is to really do a set of lessons with ML5 in a sort of high-level way to inspire and facilitate creative applications with machine learning. Part of my reason for wanting to do this, so one aspect of that is, hey, look, there's this machine learning model, you can use it and you can get the results in your code. But another thing is to really think about education and machine learning. What does it mean that our lives are more and more governed by software? Software with algorithms. Who's writing these algorithms? What data were these algorithms trained with? How can we be critical? What kind of questions do we need to ask? And so one of the reasons for doing this, beyond just here's a machine learning model where you give it an image and it tells you a classification, is to look at the whole picture. How do we go from data, training, prediction? What's that whole picture, even in a sort of toy small way, so that as you work with machine learning in projects, or as your machine learning works on you in your daily life, you can have some agency and be able to ask questions, and that is important. All right, so I'm over-explaining this because what I really want to get to is seeing if I can make a version of a machine learning model to learn the XOR operation with Tensorflow.js. And that's right. You are a person right now, I know, if you're in the East, GMT -4, I guess, or 5, I don't know what we are right now. I'm getting over a cold. Everything about today, doing a live stream right now, is a bad idea. But this is really what's happening right now. It is Friday night in New York City. I could be out where the people are out at the restaurants and the clubs or whatever. And I don't know what people do Friday night in places like New York City. I could be there. No, I'm here. I'm here to talk about JavaScript, TensorFlow, and XOR, exclusive OR, a Boolean operation. Yes, that's what I'm here to do. Hopefully, it's going to mean something somewhere. Actually, the thing is, I actively enjoy this, so I don't know why I'm complaining. This is what I choose to do. I actually like these toy little weird scientific problems. I just worry about them because I would really like to show examples and create projects that have more, unlock more creative possibilities. And I'm not sure the sort of like low-level technical nature of the XOR problem is the best for that. I'm really very conflicted, but I think we're going to move on with this. I'm going to do it. All right, so let me take a look. Oh, I have some other bad news. So in thesis presentations going on today, some microphones went up and down different floors. So that's why I have this weird microphone. I don't seem to see my batteries and battery charger. That probably also got moved downstairs. And so we're living on borrowed time here. That's why I should really get to the content here. I see 2 bars on this microphone, 2 out of 3. So I think with 2 it's probably going to last. But as soon as the batteries die in these microphones, I'm done. Also, by the time it's 8 o'clock, I really got to get home. It's Friday, the weekend is here. I've had a very long week. I'm going to eat some of my space melon. I'm telling you, this novel idea, Coding Train used to be brought to you by water, which was good, soothing on the throat. I have to talk a lot. I tend to talk a bit too loud. I get overly excited. The melon, it has a high pH, by the way. I can't believe I got this wrong. I kept saying it had a low pH because I was thinking it's low acid, but low acid is a high pH. So it's very soothing on the throat. I've learned this. I can't really eat citrus. I like citrus, but it hurts my throat a lot. Okay. Oh, I wanted to mention a couple other things about Tensorflow.js. 2 things that are new that are really relevant to what I'm talking about here are TensorFlow models. That's not anything you can see. Not even close. I don't need to write that down. The 2 things that are new is similarly to some of the things that we're trying to do with ML5, Tensorflow.js released something called TensorFlow models, which means some code that you can import into your JavaScript project with that just has the pre-trained model and allows you to call like a single function to pass in some data and get the prediction back. So for example, I believe one of the first models released with this a way of releasing stuff from Tensorflow.js is the PoseNet model. And so the PoseNet model takes a 2D image and gives you, assuming it has a person in that image, it will give you back a set of points which map to the skeleton of that person. So this is something that also, once we get down to ML5, we'll be looking at. So this whole picture is pre-trained models, training from scratch, and also what's that place in the middle? Oh, am I excited to do some transfer learning or some like, I was spending a lot of time today reading about variational autoencoders because it's a thing that I don't totally understand. I think I got it a little better. I think we should make some variational autoencoders because that's the kind of thing where you can generate some fun, interesting stuff. So that's all. And I don't know if there's any way around this. I've got to make some video tutorials about this stuff. I should get started with some content here. All right, let me check the chat. All right, everybody. So where do I want to begin today? You know what? I have this crazy idea. It's not my idea. Thank you to Me I Am So Me. Actually, somebody else had this idea. Well, two people had this idea at once. So let me go to Rainbow Topics. And let me go to here. All right, so I'm looking at this, and then what I want to do is go to thecodingtrain.com, coding challenges. Here, live example. This computer is totally on its last legs. Maybe this doesn't have a live example. It should. Oh no, because I made it in processing. I didn't upload the port yet. That's fine. Let's open it up in processing. Let's see, file, open, recent. What's the chance that I've got this somewhere? Desktop. No, I probably, water ripples. Let's actually go to, I made some fixes to the code, so I want to get the fixed code. Let's go to water ripples. Water ripples. Let's paste this in here. Okay. You can see the water ripples. There they are. All right. So that's good. Okay. And here we go. Now I need, let me get the Atom editor open. And here we go, perfect. All right, what am I doing here? Let's see, terminal. And all right. Don't worry, something's going to happen soon enough. Oops. And all right. Okay, let's whoops. Okay. All right, so Oh, I like it better when it's purple, which means I have to eat it over here. Okay, so let me cycle these cameras. And we're going to get started. I'm going to do the first video today. So this, I don't think this could be considered a coding challenge. We'll see what I want to call it. I kind of feel like, though, it should just sit here as like a bonus tutorial right here in between step 4 and 5. That's what I sort of think. One thing I want to do, actually, just really quickly, if you can bear with me, I'm just going to change this to, just so I don't have to operate it. Whoops. Oops, this needs a floor to also. And where's the dampening? If I make this, just out of curiosity. Sorry, I just want a nice visual. I'm just curious, what happens if I do this? There we go, let's do that. All right. Code, browser, processing, Java. All right, here we go. So this is going to be crazy. Hello. What I'm about to do, do not try this at home, people. This is another video as part of my videos on Tensorflow.js. Shoot, let's just start this one over. Why is the whiteboard missing? Oh, there it is. Here we go. Hello, everybody. Now, I have something very important thing I need to say. Do not try this at home. What I'm about to do is incredibly dangerous. Sparks will be flying, bugs will be rampant, and it's just not a good idea. But it's an interesting problem that I'm going to attempt in this video, which is part of my video about Tensorflow.js. In this video, I'm not going to do any quote-unquote machine learning. But I am going to use Tensorflow.js. So I recently did a coding challenge where I created a water ripple simulation, 2D water ripples, based on an algorithm by Hugo Elias that's been on the internet for a while. You can go watch that video if you want to see me build that water ripple simulation, which is running and processing right here. Now, interestingly enough, right after I did that, a message came through. Beep, beep, boop, 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 boop. That's what it sounds like, my notification sound. Came through on my coding train topics repository where you can file an issue to make a suggestion. And from GitHub user Niku Daishko wrote, during the live session, I noticed that this pseudocode, et cetera, can be rewritten in terms of matrices. Look at this. Conv2D, buffer1 kernel, interesting. A kernel is this. Perhaps it would be easier to explain what convolution is on this example. And look at this. Then GitHub user me, I am so me writes, yes, I thought about that too and decided to implement it here for kicks. Now I have looked at this code and I've had a discussion about this code. So I'm not doing this with no preparation whatsoever, but this is an interesting idea. Could I, the matrix math, all of the mathematics required to generate this simulation, could I do it with Tensorflow.js, tensors, and operations? Now, is there any value in doing that? I'm not entirely sure. But for me, and for hopefully for you watching this, this will give you another clue into new features that are part of Tensorflow.js that will be important for certain machine learning algorithms. In particular, I would like to do an image classification example that's going to involve something called a convolutional neural network. And so this idea of a kernel, this idea of a 2D convolution. And then also, if I'm working with images, there are some functions like toPixels and fromPixels. And don't quote me on this. I might not have the Tensorflow.js API exactly right. But this is stuff that's going to be necessary foundational knowledge to build some of these examples. So why not explore it in a place where I could see, in this context. So this is what this video is. Boy, I took a really long time to explain that. Thank you if you're still here watching. Thank you. It's really nice of you. I am going to try to recreate this water ripple simulation using Tensorflow.js tensors and operations. Shall we just get started? Let's get started. Oh yeah, look at that. We've Alka in the chat has pointed out a bug here. The points on the edges don't get cleaned up. So I should really deal with that. Somebody can submit a pull request or I'll do a whole other video fixing that. But it's kind of it's a feature, as one might say. All right. So I'm going to close this. I'm going to close this. And what I'm going to do, I think what I'm going to do, weirdly, is let's grab just some bits of code here. So let's grab this. Are you seeing what I'm doing? Yes. So I've got a sketch here that's already set up with Tensorflow.js imported. I wonder actually, I think time out for a second. Excuse me, I'm sorry that I just coughed so loud without muting my microphone. I'm getting over a cold, and it's very unpleasant. Although I feel so much better than I did earlier this week. Let me mute my microphone before I blow my nose. I'm going to walk over here and mute my microphone and blow my nose. I'll be back. Did I mention that I found my undergraduate linear algebra textbook recently? And that look, there's like highlighted stuff in here, and I wrote like notes in the book. There's all these like page numbers, like a secret code, like what's on all these, page 207 to 8, page 209, page 210, like what? That's definitely my handwriting. Page 247. Look, ooh, I'm like trying to do all this stuff. I did all this. Was it a dream? Was it real? Did I learn this stuff and then completely forget it all and have to relearn it in my 40s? I think so. All right. What I wanted to check really quickly, and I'm going to just check it on this computer. No new version yet. Okay, thank you, Miyayam Sumi. I was about to start talking about how there's a bug that Miyayam Sumi discovered, filed an issue that's related to the toPixels or the fromPixels function, which is a memory leak, which has recently been fixed. But anyway, we're just going to move on. All right. Yeah, if I ever create a JavaScript library, I'm definitely calling it melon.js. Or would that be weird? Is there something weird about that that I'm not aware of? That I'm not thinking of? Maybe that would be weird. But I know people don't like melon. They eat the fruit. I said this already. They eat all the berries and leave the melon. But the melon, I know it's like, but nobody puts a good fresh melon in a fruit salad. Anyway, what are we going to do? All right. Okay, so all right, so let's go back into the code. Now, what do I need here? Oh, no, wait. Now, all of this is Java code. So first, let me convert this into JavaScript. And let me say function setup and create canvas. And we're in good shape here. Now, a couple things I want to do. I want to use Tensorflow.js. So I don't want to create just an actual two-dimensional array called current or previous. I want to create a tensor. I don't even remember. I did make these videos a couple weeks ago. I don't totally remember how to do this. So I'm going to something like tf tensor2d, and then I give it the shape like it's columns by rows or something. Like this is basically what I want to do. Right? I want to have a tensor, and then also the dampening value, which is a scalar number. And by the way, damping, just calling it damping is fine. I don't want damping equals tf.scalar 0.99. So I want to start creating the data in my program that's storing all the information as tensors. Now here's the thing, I'm missing some. I've got to give these values, right? So I think there is a function. We can go to the TensorFlow API. And I'm looking for, there is a function called zeros, I think. So zeros is a function that will create a tensor with all elements set to 0. That's good. That I want to do. So actually what I want to do is do tf zeros, columns and rows. And I just noticed in there, there's also this function zeros like. Look at that. So if I've made another tensor with a particular shape, I can actually just recreate it by saying zeros like current. So this is good. Okay. So now I have my current and previous as tensors. Let's I'm going to make a 100 by 100 canvas, and I'm going to say current.print and previous.print, just to see that everything's working. What's going on here? I'm not running my code. In the right directory. Did something get reset? Am I editing the wrong file? Did I not hit save? Oh, there's another setup down here. Thank you. All right, that, Mathieu, you can edit that out. All right, let me go and run this code. Oh, oops, hold on. Whoop. Go run. Let me go run this code. Oops, zeros like. Great. So we can see there are the two, there are the tensors. Here they are. They're great. All right, now. So I've done my setup. Now, what do I need to do in draw? If we look at what I did in my processing sketch, I did an operation where I looped through every single pixel and added up. Whoa, okay, let me think about this. Let's go over to the whiteboard. This is exciting. So I have current and I have previous. I have two tensors, current and previous. Now, individually, I might look at any given pixel here in current. And what any given pixel in current is it's a function of this set of neighbors, the pixels, the neighborhood of pixels around the corresponding pixel in the previous. And it's basically this pixel divided by 2 plus this pixel. And I don't know why I'm calling them pixels, because even though I'm going to map them to pixels, it's really just data. It's just numbers representing the height of the water at any given part. I just really want to start this whole thing over again. I feel like my mind is wandering. People are going to bed, which is what you should do right now. And actually, if you look at the original link where the algorithm is described, I think these are also called like buffer 1 and buffer 2, which might actually make more sense. I don't know, whatever makes sense to your brain, name your variables that way. So current of a given pixel index equals the sum of the one to the right, the one to the top, the one to the left, the one to the bottom, each of those divided by 2 all together. So what am I trying to get at? This is actually, what we're performing here is a convolution. Time out for a second. Do I want to, what's the chance that I have like a working version of Photoshop on this computer? No. Okay, never mind. I was going to show sort of convolution in Photoshop, but I'll skip that. So how could I represent that numerically? So one way I could represent that numerically is with a matrix describing, so this is a 3 by 3 matrix of weights, so to speak, a weight for each pixel. The corners being 0. I'm going to ignore the center for a second and make that 0 as well, and then all of these being 0.5. So applying this kernel to any given pixel mean take all the pixel values, multiply it by the weight, sum them all together, get the result, and put it in the new spot. This is what's known as a convolution. Two-dimensional. This is a convolution in 2 dimensions. This could be 3 by 3, 5 by 5, but I'm going to use a 3 by 3 matrix to describe all the weights. Take half of all of these neighbors, multiply it by the pixel values, add them all up together, and put them in the new value. So what we need is to create this kernel as a tensor in Tensorflow.js, and then we need to apply the convolution 2D function, which says, hey, take this kernel and apply this convolution to every value in the tensor and make a new tensor out of that. All right, so let's go see if we can write the code to do that. All right, so if I'm coming back here, what I want to do now is I'm going to add another variable called kernel. And I'm going to say kernel equals 0, 0, 0. It's going to be like a 2-dimensional array. I'm going to write it like this. And let's see how I can make this look nice and satisfy all of my urge to have everything aligned and indented. Okay, no, these have to be 0, 0.0, 0, 0.0, 0.0. Okay, oh, and this one should be 0, 0.0. Okay, so now you can see this kernel. This is the kernel, but this is just the data expressed as a plain JavaScript array. So I want to make this into a tensor. So I should be able to do this. And let's think about this. So hold on. Time out for a second. This computer went off. I also only have one power plug today. So I can't see. Come alive, my computer, with the Slack channel where everybody's telling me how I'm doing everything wrong. There we go. It's waking up, folks. I'm going to have a piece of melon. Which one has seed? I'm alive, computer. Okay, so far in the chat, I don't see anything that I've done that's horribly wrong. Okay, refresh. Do I have internet here? No. All right, now. The internet back. This has crashed. Ugh, no, I do not have the internet back. Sorry, everybody. There we go. Okay. All right. There we go. I'm back. All right, so let's review for a second. I've got the damping value as a scalar. I've got the current and previous matrices of numbers as tensors filled with zeros. And I now have a kernel which I can apply as a convolution. And this is the stuff that I need to do in draw. So in theory, this entire big loop here, right? This could now be done as, right? The idea here, what I had to do previously is like loop through every pixel individually, add them all up, dividing by 2. Boy, I'm missing some dividing by 2s in. Is my code just totally wrong? Hold on, I think I found a bug in my processing code. Hold on a sec. Let's go reference that original algorithm. Let's go here. 2D water, here's the. Oh no, oh, the whole thing is divided by 2. Okay, yes, I did this right. But this is, no, the divide by 2. Okay, everything was right here, never mind. Rewind. I'm sorry, I keep coughing into the microphone. I hope that isn't too horrible. All right. This is not going so well today. This is not my finest work. I'm losing all my confidence too. Not that I ever had any confidence. All right. Mathieu, thank you again for all of your editing work. Looking at this, I have to iterate over every single pixel, add everything up individually, multiply by dampening, store it in the back into the array, and then write the pixel. So this whole loop should be something that I can do just a single operation to. For example, there must be some way for me to say like next equals TF convolution 2D, like apply, I'm just making up the API for Tensorflow.js, then we're going to go look it up. Like apply this kernel to this tensor and give me the results of that in a tensor, right? So this is like a single operation to say, take this kernel and slide it over every pixel, update all the values, and give me a new tensor back. Hopefully this is, so let's actually look at the Tensorflow.js API, and let's look for the convolution 2D function. So I think it must be under operations. Convolution. Actually, there's just a convolution section. So I'm going to click this here, and now we're going to look at the function. Okay, it takes a set of values with a filter. Now, there's all sorts of other stuff that are involved in a convolution. Strides, pad, but I'm going to ignore all that for right now. So actually, I didn't do this so terribly. So, but here's the thing. X has to be a 3D or a 4D tensor, rank 4 or rank 3. That's weird. Why is that? Because mine was certainly I just have a 2-dimensional tensor, right? Columns and rows. Well, if you think about it, convolutions are designed to work over a matrix. And if we're working with an RGB image, there actually could be inside each one of these pixels 3 values. So the shape for that would be width, height, 3. So even though I'm working with this sort of grayscale image that just has a single value for every spot in the tensor, I need to explicitly set the shape as width, height, comma, 1. So let's change it to a rank 3 tensor. And it could be a rank 4 tensor if I had many, if I'm batching a set of data, probably. So I'm going to do this, comma 1. Okay, so that's good. That's fixed. Then the filter, Tensor4D, the filter, rank 4 of shape. Filter height, filter width, in-depth, out-depth. Okay. So here's the thing. I've got to explicitly say this filter, right? This is a 3 by 3 filter. So I have the shape just as 3, 3. But really what I also need to specify is what is this applying to? How many values? Is this applying to an RGB, three values? And then when it applies to all those values, is it summing everything into one value? Or is it doing each one of those individually and we should get 3 values out? So this actually has to be a rank 4 tensor. So one way I could do that would probably be like just keep adding brackets. But there also is a nice function, I believe, yes. So this function as for D allows me to convert a tensor to a tensor 4D, and I just need to give it the rows, columns, depth 2. So I think what I need to do here is say as for D, 3, 3, 1, 1. Right? So I want to like write my tensor. Maybe I even just want to do this, because I just want to see it as like a list of numbers, and then I want to use the as4d function to reshape it. Okay, how am I doing? So now I should be able to say next equals, and then look at this. So the convolution function takes the values and the filter, another word for kernel, second. So I'm going to, I need to say previous and then kernel. Okay, so that's next. So I'm not using current because if we look at the actual original code, what I did just now is I took care of this, right? I took care of adding the neighbor to the left, the right, the top, the bottom, dividing by 2 with that kernel, but then I have to subtract out current's actual value as well. So what I would need to do now is say, I need to make another tensor. So I need to say next, okay, I need to subtract, I need to say minus the current value. So there should be a subtract operation. Subtract, where are my operations? There's an add, multiply by -1. Basic math. No, add. Operations. Hold on, hey Mathieu, let's go back a second and let's not have me searching for operations for an hour there we go. All right, so I want to look for operations, and here we go, TF sub, which means subtract. So what TF sub does is I can subtract 2 tensors, A sub B. So I need to say next sub current. And then I need to apply, what else? So look at this. Well, this is like, then I need to multiply by the dampening. So I could then say also next equals next multiply damping. But one thing that Tensorflow.js allows is chaining. So each one of these returns a totally new tensor. Remember, these tensors are immutable. I'm not made them variables here. So what I actually could do probably is say subcurrent multiply damping. But I just can't bring myself to do that. Maybe I could bring myself to do this. I'll do it in 2 lines. So I think that I've got this right. Alka's giving me a great tip for searching in the reference. Search for tf.sub instead of just searching for sub. Thank you for that. All right, so next equals, so I apply the convolution, I subtract the current, I multiply the dampening, and I'm done. Thank you very much. Now, how do I see the results of this? Well, there's a couple different ways I could do this. One is I could ask for the values. So I could say, all right, give me the pixels are, next data sync, which would, I know the camera went off, everybody, don't worry. It didn't even make a noise that time. That was weird. All right. So what do I want to do next? I would like to draw the pixels. I would like to see the water ripples. I mean, I've done the steps. I know that I need to, at the end, say something like previous equals next. Well, I need to do the swapping. Let's not worry about that. So I still need to do the swapping algorithm at some point at the end. But really what I want to do now is I need to display the water ripples. So one way I could think about doing this is actually just ask for the values. So I could say something like let pixels equal next dot data sync, which is a very bad idea for many different reasons. But this would, in theory, give me a big array of all the values, and I could run a loop and I could set all the pixels. Because working with images and pixels is such a common thing in machine learning algorithms, there are some helper functions for this. So there's 2 pixels. So draw a TF tensor of pixel values to a byte array or optionally a canvas. So this is what I want to do. Returns a promise. Interesting. Interesting. Let's see how this is going to work. Image, canvas, question mark. So what do I want to do exactly? I'm thinking about this. How does this work? So how do I say this? Do I say next 2 pixels? Or do I say TF? How does this work? Hold on. Let's read this. Draw a TF tensor of pixel values to a byte array or optionally a canvas. When the data type input is float 32, we assume values are otherwise blah, blah, blah. Returns a promise that resolves when the canvas has been drawn to. Oh, boy, it would be nice to read this a little further. Okay. Hey, Matthew, I'm going to do that part over. Oh, I'm the worst. So let's look for let's look for 2 pixels. Here it is. Okay, 2 pixels takes 2 arguments, image and canvas question mark. Draws a tf.tensor of pixel values to a byte array or optionally a canvas. So I want optionally a canvas. Hello, I want to choose that option. So what are the parameters? Image is that tf tensor, which actually it looks like it can have different depths, like but I have a rank 3, which is going to work perfectly. So image is my next, and canvas is the canvas element. So I want to say TF. So I don't need to. I just want to say TF 2 pixels, next, comma, and then I need a reference to the canvas. So I need to create a variable, store the canvas in that variable, and then probably just say a canvas.elt. And it's going to do this asynchronously. Let's just see what happens here. Let's just see if I can even get any errors. Cannot read property 0 of undefined. So where's my object end up? Oh boy. Oh, first of all, I have not thought about my memory management yet. I've got to come back to that. But what's wrong here? Ah, canvas.elt is probably not the right thing. So let's look at the P5 object. No, the ELT is the canvas object, but then I need to actually get the. So whoops. We need some melon. Oh. Oh, really? Yeah. Me, I am Sumi is writing in the chat. Turns out that P5 exposes a global canvas var. I don't want to use that though. Let me see here. Canvas. That's the same thing. That's weird. That's nothing. No, canvas.canvas is right. Canvas.elt is right. Well, actually, what's the... So, all right, so let's do a little debugging here. Let me comment this out. What's triggering that error? Yeah, that error is actually not even happening here. Is my subtract triggering the error? Nope. Is my convolution function triggering the error? Yes, it is. It most certainly is. And let's take out these prints. So what's wrong with this? TF convolution 2D previous kernel. Let's look again at the API, tf.convolution2d. Let's go here. X filter. Filter. So let's look at, oh, no, this is right. It has 4, okay. So convolution 2D has 4, oh, I have to give the strides and the pad. Okay. I didn't want to have to explain. I thought there'd just be some defaults for strides and pads. So that's definitely the issue. Yeah. Hold on, I'm just checking something here. The pad is like how much padding along the edges, right? And the strides is like how far I go with each one. So I think that's just 1 and 1 is what I want. Is that right? Yeah. So, oops. Oh, valid, same, or a number. It's number, or just a number. Stride height, stride width. Okay. There's more info here. All right. So the error is definitely here in the convolution 2D function. And actually, I just didn't read the documentation very carefully. The way this documentation is written is that the optional arguments are written with a question mark, and strides and pad are required. So these are important pieces of how a convolution works. Let me just briefly mention what I think they are. So I believe a stride has to do with how many pixels should do I do as I move along. Like I could apply a convolution but skip pixels, and so my stride could be greater than 1, and it could actually be different in height, in width and height. And a pad, I believe, has to do with like what sort of padding to apply to the edges. Because you'll notice if this is a 3x3 matrix, if I go to the edge, I don't want it to like fall off the edge. So maybe a padding. So I think what I want is I just actually want to do every single pixel. So I want a 1, and then I want a padding also of 1. Although can I have a padding of 0? Because I actually don't want to lose any information. Let's try this. But actually, it also has valid same. Oh, yeah, same and stride 1. Ah, this is what I want. It's actually written right here, except you can't see it because I'm standing in front of it. So I want a stride of 1. I want output will be of the same size as the input, regardless of filter size. This is what I want. So I want to say 1 and so I want to say 1 and same. So I think those are the arguments I need to add. Whoops, where am I here? Hey, no more errors. Whoops. And there we go. Look. It's actually, you can't really tell, but this has displayed that, right? Because if I comment this out, you don't see that black square. This is actually working, right? And if people were asking in the chat what this .elt is, so Canvas is a P5 element because I'm using the P5.js library. The P5 element stores a reference to the native HTML5 element in the ELT property. Tensorflow.js doesn't know anything about P5, but it knows about HTML, so I can pass the two pixels function that canvas.elt. Okay, so let's think about the swapping now. So what do I need? I need previous to now be basically current, which is next, and then current. Let me think about this. I did the swapping. Let's just look at this swapping here. Right. Okay. So what I need to do is store previous. Set previous equal to next, and set current equal to previous. So this should be the swapping, and I suppose I could have just continued to use current here, right? I don't need that next. No, I don't want to do that because I need to subtract. I need to subtract out. That's a bad idea. So I think that I need to keep this separate. Yeah, I'm not. Let's do that. Okay. All right. Oh, thank you. Current equals temp. There we go. I just do all of this many times over again. Let's just go back. All right. All right, I'm going to add the swapping algorithm now. The swapping algorithm takes what is now the new current pixels, saves them in previous so that the current becomes the previous for the next time around. And so we can look at what was here in the original code. Now all I need to do is say let temp equal previous. Previous equals not current though, next. I created a new variable called next in order to do the calculations with Tensorflow.js. And then current equals temp. So this should be the correct swapping. And now, let's run this. Hey, it's running. Look at my water ripples. I'm just curious, like, what's the frame rate? Yeah, it's running at 30 frames per second. Totally reasonable. It's doing all these calculations. Let's make it 600 by 400, so it's a little bit bigger. Whoops. Oh, that's not it. I ran the processing sketch by accident. And here we go. All right. All right. Now, we need to add the ripples. Could I possibly, I could, like, how do I add the ripples? All right. Now, this is tricky. This is really tricky here. Now, you might recall, let's just say for the sake of argument that in mouse pressed, I want to add a ripple at mouse X, comma, mouse Y. And if we look at what I did in the processing sketch, I added those values to previous. So somehow I need to take this previous tensor and I need to change its values. How am I going to do this? Well, I could go down this rabbit hole of making it a variable, but I don't really think a variable is really, how do I want to explain this? Did I get something wrong in the temp equals previous, previous equals next, current equals temp? Do I have it wrong? People are, I can't tell in the chat if you're just discussing it or, yeah. Yeah, I should generate a random tensor would be good to just sort of start this. What do I have wrong here? Previous equals current. Oh. I don't see this. Oh, I should just set current equal to next here. Wouldn't this be right if I did this? Yeah, I don't need... All right, let's think about this. This applies the kernel to previous. Then I subtract out current. So next is now what I want to be in current. I'm not seeing this for some reason. Oh, this is wrong. That's for sure. This definitely needs to be next. And then, shouldn't previous be next? Oh, I see. Previous I gotcha. Can I just do this? I can just do that, right? People are telling me I'm doing it wrong. Previous equals current. Current equals next. Oh. No, I don't think you were all right. This does not make any sense. Because setting previous equal to current, I don't believe this is correct. All right, people are telling me, I don't believe you. I told you this was a bad idea. All right, let me find some empty space here. This are the values of current. These are the values of previous. In my processing sketch, I rewrite all the values of current based on previous and current. Then I point previous here, and I point current back to here. Now, instead what I do is I have this variable called next, which I write all of the values that are a function of previous and current into here. That's next. Are you with me so far? Am I correct so far? Now, what I want is for previous what I want, next and current are supposed to be the same. Instead of overwriting current, I've just written everything to next. So shouldn't previous point to next? Why should previous point to current? In processing, you're updating previous to have the next values, then swapping it. Here you're not swapping, you're discarding previous. In processing, no, I'm updating current. And then I'm updating previous to have the next values. Oh. But the next, the equivalent here would be let me write the equivalent here. Next equals new float columns rows. Then what I would say here is next equals all of this. And then next equals next times dampening. And then current equals next. Right? Wouldn't this be the same thing? This is exactly the same thing. So I don't see why right? Look how this works. So why here can't I just say this exact same thing? I know there's a little bit of a redundancy here. Why is this invalid? I don't need to, why does the title say Friday? It's Saturday. I believe I am correct here. The reason why I have a next, I should look at I.am Sumi's code here. Let's look at how they did it. Boy, I really, I see. Temp 1 is current kernel. One same. I did previous kernel. I'm just doing it my own weird way, that I'm using previous as the starting point. I should have just named them buffer 1, buffer 2. I kind of like the idea of this, though. Oh, I see. Barangello is explaining this. In processing, you use current var directly. Here you start with zeros and add current to it. Ah. Yeah, but this should still... if we look here... Man, this is okay. This is exactly the same now. Adding the convolution, subtracting out current, multiplying the dampening, and then doing the swap. I know that this I see that me is doing this a different way. That's just not the way my brain works, right? We could apply the kernel to current. Subtract, this is just like reversed. Then dispose. I have to deal with the memory management stuff. Oh, interesting clipping is happening here too. There's lots of interesting stuff here. Tidying things. All right. I'm going to move on. This is one of those ones where I should just, melon. My last piece of melon. This is one of those ones where I'm just going to have to redo the whole thing. This can't get edited together. Yeah. Yeah. Yes, exactly. I'm right. All right. Let's just for the... So let's go back. Interestingly here, okay. All right. Current never actually means current. I know. But it would if I did this. The problem with me doing this is if I lose the reference to current, I can't dispose of it, but I could run tidy on all of this probably. I think I should just change this to buffer 1 and buffer 2. All right. Yeah. Hey, everybody. I'm back with a weird edit point because I went down a horrible rabbit hole because the words current and previous can make things very confusing. And so I actually want to just go back to this algorithm and I'm going to change the things to buffer 2 and buffer 1. Just bear with me for a second. I'm going to change, and you know what's going to be so nice about this? Buffer 2, buffer 1. Because if I name them that, then they have the same number of characters and everything aligns really nicely. So I'm going to say that buffer 1, and I don't know why I wrote this in the other order. I'm going to say this is buffer 1, this is buffer 2, this is buffer 2. So now I'm going to do these operations. I am actually going to say, I'm going to make this I'm going to call this not next, but temporary. And the reason why, and so this is buffer 1, which was my previous, basically. And this here is buffer 2, right, which is what gets subtracted out. And buffer2 is equal to that. So I could say here, I could just do this. Buffer2 is the result of that convolution, and then buffer2 is the result. But there's two problems with this. Number one is I need to subtract out the values of buffer2, so I don't want to overwrite that. So I need a temporary one here. But plus, I also might, I'm going to have to deal with memory management at some point because I'm making all these extra tensors. So now I should be good. I have this temporary, which is the thing that I now want to draw. But what is temporary really? Temporary really is buffer2, right? All along, temporary was standing in for buffer2. All along, temporary was standing in for buffer2. And so now, buffer1 now I need to do the swapping. Hold on. I have got a mistake here. This should be this should be temp. Yeah. So right. Okay. So temp. So temp. Apply the convolution. Subtract out buffer2. Buffer2 is actually temp. And now let me do the swap. The swap is temp. Now I think I have some redundancy here. So I'm going to clean this up in a second because I have an extra temporary variable already. So temp equals buffer1. Buffer1 equals buffer2. And then buffer2 equals buffer1. So this is the swap. This is your traditional swapping algorithm. Do I need this extra temp? Because do I have buffer1 stored somewhere if I overwrite it? Not really. So I'm going to call this temp1, and I'm going to call this temp2. But because I have this, buffer1, yeah, so equals temp2. All right? So this, my brain is hurting a little bit. But basically, and so I probably have something extra here, but I think this is right. Okay, so here's the thing. Whew. I've done a horrible job of, I've got to deal with the managing memory, but I think we're good now. Let's run this code, and let's see. Current is not defined. Sketch.js line 24. Oh yeah, zeros like buffer1. There we go. Temp is not defined. Sketch.js line 37. Oh, because I called this temp1. Temp is not defined. 41. Yes, temp1. Temp is not defined. 43. Temp1. All right, we're going to get there. Okay, good. Now I just need to add a ripple now. So what I'm going to do here, all right, we need to figure out how to do this. So if you recall in my previous videos about tensors, these are immutable. What I want to do is change a single value inside of buffer1. I need to change a single value inside of buffer1. So if I could do something like this, buffer1 set, mouse x, mouse y, 1. If this were just some sort of magic thing that I could do, where I could just set a value because I could change it, then every time I click the mouse, it's interesting that's not giving me an error. It's like an actual function. Whoa, hold on. Is there a mouse press somewhere else? Oh, there is. Yeah, once again I fell for it. Seriously, how many mouse presses do I have? Oh, mouse pressed. My E key doesn't work. Let's go back. Wouldn't it be nice if I could just do something like write function mouse pressed, buffer1 set the value at mouse x and mouse y to 1. Just set that value. Let's see what happens. Right. So that's not a function. These tensors are immutable. I can't set a value in them. So I could turn it into a variable, which is supposedly a way that a tensor can be changed. But variables are really reserved for tensors that you want Tensorflow.js to optimize with its own kind of internal algorithms, the optimize function, the training function. So really what I want to do, unfortunately, I'm going to need to basically pull out all the information, change a value, and put it back in. I think that's going to be the way that I want to do this here. And so the way that I'm going to do that is by saying tf.buffer. So tf.buffer, it creates an empty tensor buffer with a specific shape. So this is the way, this is basically taking those values and putting them in a typed array off of the CPU to a place where I can start like messing with them. So what I want to do, let's just look at this. So I want to say let buffer equals buffer1 dot buffer. Oh, I shouldn't have called my things buffers. This is bad, very bad variable naming. Let's look at this. Oh, this is actually not what I want. This is not what I want. This is a function to create a buffer. And what I actually want is not the creation of a buffer, but I want to look at the tensor class, and I want to look for the buffer function here. This is what I want. Returns a TF buffer that holds the underlying data. So I don't need to, this is what I want. I want to get that buffer. So let's take a look at that, what it looks like. So we can see there, that buffer came in and it's got all those values. Now, look at the shape, 600 by 400 by 1. That's good. Now I should be able to use the set function. Let's go look at Tensorflow.js, and what I want to look for now under TensorFlow buffer set, value at a location. This is the location index. So I should be able to say buffer.set, the value 1. I want to set that value to 1 at mouse x, mouse y, 0. Now remember, the 0 is because I have I'm thinking of this as a grayscale image. If it were RGB, I might be setting this at 0, 1, or 2. But there's only one value there. So I think this is right. Then what I want to do is say buffer1 equals buffer.toTensor. Like I just want to turn it back into a tensor. So this is me actually manually. I've talked about how somewhere in Tensorflow.js that the idea is that all the mathematical operations happen on the GPU. But for me to do anything manually, I need to pull it off of the GPU. That's me making it into a tensor buffer. Then I can play with the values, and then I can make a new tensor back. Now, again, I haven't done anything with memory management, but let's see here if this actually works. Okay, the number of the provided coordinates 1 must match the rank 3. Value locations, the location indices. What did I not get right here? Let's look at this again. Wait a second here. Miyamsumi is writing in the chat. It isn't an array. You just put the coordinates in as arguments. So this is probably a GitHub issue that's worth filing on the Tensorflow.js documentation, because I think this is pretty confusing. That this is actually like an optional number of arguments that are all the different index values, it seems. So for example, instead of putting them as an array, I just, it's a rank 3 tensor, so I give it the location values, 3 more values, I think. Let's see. I'm clicking. Let's see here. let's do a little experiment here. Let's change the canvas to 10 by 10, or just, 10 by 10. Let's comment out everything in draw. Let's say buffer1.print and buffer1.print. So let's look and see. Let's see if this actually worked. Oh, wait a second. Do you not see my 3 by 3 canvas? Hold on a sec. Let's say background 0. All right, there's my 3 by 3 canvas. Let's clear this. So it doesn't look like, why is this printing it out so insanely? I gotta get rid of this processing thing. Oh, it's 10. I made it 10 by 10. I meant to make it just 3 by 3. And okay, hold on. I think this debugging is worth having. All right. So let me print these out, and let me change this to, let me go back to where I was changing the canvas size. So let's debug this. Let me make this just like a 5 by 5 canvas. Let's comment out draw. And let's actually just do all this in setup. And let's say, let's just set 3, 3. So let me do buffer1.print and then buffer1.print. So let me look at this. Whoops, this thing is still running. Let me go here. Whoops, sketch 33. I need a closeout setup. Yeah, so that worked. Something got set to 1. So that definitely worked. It is being set to 1. So that's working. Okay. So let me go back. Here. Now, I do have a sneaking suspicion that whoa, what did I mess up? Oh, you know what? I must not have saved. I think I didn't save. Okay. I must not have saved. All right. It shouldn't be so people are in the chat are asking if it should be 255. And yeah, I know what the problem is. Thank you. People are saying it should be 255. If you look at the docs, if you're using float, Tensorflow.js in this 2pixels function will assume the range between 0 and 1. So hold on a sec. Let me just. All right, let's give this a try. And now I'm going to click. All right, so what's going on here? First of all, we're getting some crazy errors. Tensor values for a float 32 tensor must be in the range 0 to 1. So actually, this particular algorithm is subtracting values and adding values together. I'm not doing anything to constrain the values between 0 and 1. There must be a Tensorflow.js operation that does that constraint, but it can't figure out when I'm turning things into pixels. Right? This is all because of this line of code. right? It doesn't care. As long as I don't turn it to pixels, I can have any values in there. But if I'm turning it to pixels, I have to have it between 0 and 1. So in this case, I need to do some kind of constraint-like thing. So let's look under operations. Arithmetic, maximum, minimum. No. Basic math, square difference. I'm looking for something that will constrain the tensor. Reverse slice, split, stack, tile, cast, expand, pad. Range. Creates a new tensor with the numbers in the range provided. It includes start, but so this should work, right? I should be able to use range, I think. So I can also say temp 1 equals temp 1 dot range, something like this. I could probably add it in here. Is that what I want to use? Or truncated? No. No. No, this is creating a tensor with numbers in that range. What am I doing here? Clone, fill, tensor, cast. What did me use? Clip by value. I just didn't see that. Range, it's not. Range, it's not. This is like actually a way of creating a tensor with numbers in the range provided with a certain step. That's not what I want to do. All right. Clip by, Thank you to the chat. I just learned that there's a function called clip by value, which basically takes a tensor and clips it within a particular range. It's the equivalent of the P5 constrain function. So I want to say dot clip. I can add this here as another chained operation by value, and just between 0 and 1. So this should do the trick. It should be another operation. So I apply the convolution, subtract, multiply, and clip. Now let's try running this. Well, I'm not getting any errors. Wait. Oh, I saw a water ripple. I saw a water ripple. It was there. It was fleeting. It's not even in the place that I clicked. Okay, so what's going on here? Dampening. Let's put the dampening at 1 just for a second here. Right there. Is there some kind of like pixel density thing going on? Something is wrong where I'm setting the values. Maybe it's this. I have the axes reversed. Rows by columns. Let's see. Huh. This was such a bad idea. This is just not. One mouse Y, mouse X, comma 0. So this is what it should be. Boy, what oh. No. Oh, no. Right. Rows by columns, right? Because it's a matrix, rows by columns. Yes. I think we've got it. Oh, look at that. If nothing else, the Coding Trains live stream is a really good representation of what it's like to really code. As you can see, I just like can't get everything wrong. It's really frustrating. I don't even know why I'm doing this. Did I learn anything? Did you learn anything? I don't know. But there we go. This is not even a faster version. No, not necessarily. I'm not even doing this. I'm just trying to learn how Tensorflow.js works. And by the way, I got to deal with like the memory management is like a massive problem here. Let's turn this off. Mathieu, I don't think we should put this together as a video. I think, first of all, it's 8 o'clock. I reached the end of the amount of time that I had. Remember when I said you should not try this at home? Well, I was right. Oh, I'm sorry, everybody. Let's finish this off. I think I should come back and do this again. I can run 100 steps at once on the GPU. Yeah, it'll be really fast. I'm not doing anything efficiently here. I'm just trying to learn stuff about convolutions. Let's first do some stuff important. Let me put all this in TF tidy because I'm creating all these tensors. And but I don't want to tidy. This is confusing now. Because I need buffer 1 and buffer 2. There's a way with TF tidy to like explicitly on the powers at 35%. Okay. All right, let's just assume for the sake of argument that Mathieu can make this into something. I don't know that you should, but I'm going to go back and explain. I'm going to go from clip from value. Okay. I think, look, there's water ripples in there, but they're like off. Something is wrong. What's going on? Guess what? I have figured it out. It took me like an hour and a half, but you get to watch this edited version. So I forgot something really important. In the world of matrix operations and machine learning and linear algebra, we always say rows by columns. This 3x3 matrix or 3x3 tensor has 3 rows and 3 columns. In the world of computer graphics, I always say x comma y. So x being like the columns, the horizontal, y being the rows. And so I must change the way that I think about everything. And this should actually be rows by columns. And then here I need to say mouse y, mouse x. All the operations are fine. And now, this, by the way, changed during my debugging session from mouse pressed to mouse dragged. Now let's see if this works. And yes, look, there are water ripples happening there. Woohoo! Yay! This actually happened. I don't know, they're so dark. I wish I could figure out a way. I set the damping to 1. Let's put it back to 0.99. And you can see that they're really so hard to see. So I got to think about a nice way to brighten them up there. Maybe there's some other tensor operation I could do to like increase the values. But here's really the main issue. tf.memory. What do I... Look at this. tf.memory dot number of tensors. Whoops. Number of tensors. 5,089. There should not be 5,089 tensors. I need to be cleaning this stuff up. So a really nice way I can clean stuff up is by using the tf-tidy function, which just says, hey, everything inside of this function, I just make this anonymous function with all of my code, and I put it inside tf-tidy, and tf-tidy basically says, like, run all this code, but tidy it up. Now, I'm going to have a problem here. All of a sudden, now, the tensor is disposed. So I really want to keep these. So what's the best way for me to approach this? Another way I could approach this is by manually, so I could use tf-keep to make an exception to certain things that I'm tidying, but let me try to manually dispose stuff. So as soon as I do this, I need buffer 1 still. Buffer 1 doesn't go away, but buffer 2 I don't need anymore. So I'm going to dispose buffer 2. Then buffer 2 equals temp 1, right? Temp 2 equals buffer 1. Buffer 1 equals buffer 2. So I think actually it's just this buffer 2 that I need to dispose. No, this couldn't be. All right, let's see here. Let me think about this. I'm getting like text messages. Right, okay, let's think about this. Okay, I got to turn my watch notifications off. Okay, hold on. All right. Yeah. Okay, let's try to dispose them manually. This is going to be a little bit insane. So I'm going to change this now to temp 2. And then after this is done, I don't need temp 1 anymore. And do I need buffer 1 or buffer 2 still? Buffer 1, let's think about that. Or buffer 2. So now buffer 2, so buffer 2 should be disposed. Because I'm going to retake it and set it to temp 1 anyway. Now this is bad. This is temp 3 now, by the way. Temp 3 equals buffer 1. Buffer 1 equals buffer 2, which is really temp 1. Whoa, so I don't want to... Oh boy, hold on. Buffer 2 equals temp 2. Oh boy, this is terrible to keep track of all of these. Okay, dispose temp 1, dispose buffer 2. And then this is now also temp 2, right? This is the end result. These are the pixels. Oh, but it's making different ones with this chaining. So without tidy, let me use tidy. Let me use tidy. This is so hard. This is so hard. Right? I mean, I'm worried about with the chaining without... all right. Well, let me not worry about the chaining for a second. Let's go with my dispose them individually. So temp 1 and buffer 2 can be disposed. Buffer 2 is set to temp 2, which I still have. Then temp 3 equals buffer 1, which I haven't disposed. Buffer 1 equals buffer 2, which is this. And buffer 2 equals... So this is fine. This, in theory, disposed everything, except for the fact that I think this chaining is going to cause a problem. So let's see what happens here. I still have the water ripples. Uh-oh. So I'm still making too many tensors. Way too many tensors. So what if I do this? The only thing I need to keep here is temp2. So what if I say tf tidy, and I'm going to use the arrow syntax just to, yeah, there's no way this is going to be a video. And then, how do I keep? Keep. Okay. So then I want to just say tf keep the result of this. So tidy everything but keep temp2. Now set those pixel wise. And then temp buffer2 is temp2. I've kept that. I'm not sure. Let me just say buffer2.dispose here. Oh, memory leak. There's also a memory leak bug, which could have been the problem. So let me dispose buffer2. And then temp3 is buffer1, which has not been disposed. And that goes into buffer2. And buffer1, so this could really just be this, temp2. And I probably need to, buffer1, I don't want to dispose. Yes, I do. Well, that's weird. Why is that? Oh, no. Oh yeah, this is going to be a problem. I guess what I need to say is, oh, so maybe I don't need keep if I do this. I just return the result of that. Right? This is what I could do. I'm so close to simplifying this more. All right, let's see here. I'm sorry, everybody. Seems to be less. Still going up. Now, there is this memory leak here. Let me comment this out. So now I have succeeded in not creating extra tensors. Was this necessary? I think it was. Yep. This went off the rails more than anything I've ever done. I think I have to go home. I'm sorry, everybody. There's no way. This was useful for me. I think this is just going to be a live stream that just lives as it lives. Clearly, I'm not staying hydrated. Made this nice thing of water. Let's see if I actually still get water ripples. Yep, I'm getting water ripples. That I have that memory leak. So this is a memory leak which we can go to TF. Where am I going to? GitHub.com, TensorFlow. Well, actually, let's go to here and let's click to GitHub. Issues, closed. Memory leak. Here we go. So this memory leak due to this issue. All right. All right. All right. Okay, everybody. I really want to understand. This could be 2 lines. Yes? I think this could be. You know what it is? It's this microphone. I can't program or think well with this weird microphone, apparently. Temp3 is buffer 1. Buffer 1 is temp2. Oh, I see. I don't need that. Whoops. There, I did it now. Right? Because buffer 2 is buffer 1. I don't need that temp 3. And buffer 1 is temp 2. It's just like temp 3 could not have been disposed. Temp 3 it wasn't creating a new tensor, it was just another pointer to that same one. This if I'm ever going to do it, I mean this I think was useful for me in like learning Tensorflow.js a bit more. Have you heard of how Adam Savage wears his mic? He has a hole cut in his glasses rim. That's interesting. No, temp3 wasn't the memory leak. It just was an extra variable. I was using it to store buffer 1. I don't even remember what I had before now. Just copy this. Yeah. I was using it to store a reference to buffer 1 because I need to set buffer 2 to that. But in this case, because I could just do that first, right? I don't need I'm not actually swapping 2 values. What I'm doing is I'm just saying buffer 2 is equal to buffer 1. Buffer 2 now becomes buffer 1, and buffer 1 is the result of all this math that was done up here. Okay. Look at this. This is so little code. You would think that I would be able to do. I think I could do this again if this is a useful. So about that 24-hour live stream. Now what's a quick way for me to make this brighter? I mean, what's an operation I could apply to the tensor? I could multiply it by Or I could square it, like, right, I could multiply it by 5, right? I mean, this is sort of silly. Like, what if I multiply it by... Oh, no, but I have to clip it afterwards. Well, no, but the damping, this is... Or add to it. Let's do something crazy. Ooh, I like that. This is like additive blending now. All right, everybody. I'm so sorry. I went down. I should have known better. I should have had better judgment. And I shouldn't have started with this. And I should have done the layers API and the XOR coding challenge, but that's just gonna come next. I have to be done now. It's 8:20. This I will publish. I'm looking at my phone right now. Oh, I'm on the wrong screen. All right. Change the kernel values to 1. That's an interesting idea. Let's change them to 1.5 for fun. I like 0.9. Six. Interesting, yeah. That 0.5 is really a magical value. All right. Try 2 pixels inside a tidy. No, I think that's just... Yeah, that's an interesting idea. I should try that. I don't think that will fix it. But yeah. No, it's still it's a bug. Yeah. Just do the normal I posted I beg ya. What's that thing? Anyway. So let me talk about this other thing I want to talk about. I'm going to actually unlock a feature right now on YouTube. Can't pass the location of a literal to a function. All right, so first of all, what's happening with the calendar? This was I wasn't planning on live streaming this week because I had thesis all week, and I usually have Friday evening as not available, but I was able to make it work for this evening. But unfortunately, I didn't waste the time, but could I do a quick? I should just do like a quick coding challenge before I go. Hold on. Yeah, it's clamped to 1 is the issue, I think, is one of the issues. Like what I should do is actually, I have an idea. Pixels. equals temp to clip by value. Was that what it was? And then do this, and then dispose it. So I can let the tensors actually have larger numbers. Right? Check this out. What did I do wrong? Oh, whoops. No. Watch this. Let me not dispose this for a second here. Okay. Now what I can do, there we go. So this I need to dispose this one. I could do tidy. There we go. Yeah, no, it's disposed. So this is like asynchronous. This to pixels thing is asynchronous. So I have to dispose after. All right. So I would have to do this, then pixels.dispose. I think this is what I would have to do. There we go. Oh, there was a super chat. Thank you, Nuka Charlie. There we go. Now I've made it brighter so I can see it. So much advanced, crazy stuff in here. You know what I need to do? I need to slow down. I need to come back with fresh energy, fresh thoughts, and try all this again. All right, this is good. I'm learning Tensorflow.js. Becoming more of an expert in it. One day I'll be able to say, I am an expert in Tensorflow.js. All right, so there we go. So here's the thing. I'm just curious, for those of you watching right now, I'm going to make this so I got a couple things to talk about here. YouTube.com/thecodingtrain. All right. 731. I can't believe there's still 731 people watching. That would be insane. So what am I logged in as myself? That's dangerous. Okay. Going to community. Okay. So let's, dear diary. Tonight, I had very special plans. My dream, the live stream, the topic, is to continue my tutorials on Tensorflow.js. I planned to cover the layers API, and show how to train a model to solve XOR. This would have been beautiful. Instead, I decided to recreate the Water Ripples API, the Water Ripples coding challenge with Tensorflow.js. It involved so much debugging and me being confused over and over that it took hours. What should I do? Sincerely yours, Choo Choo. Poll. Okay, what should I do now? I should leave it be. It was a moment to live only in the moment. Leave it be and move on. It was useful but insane. Do it again as a tutorial now that you... okay, and the other one is... just edit it together somehow. No, this is a bad idea. Don't vote for this one. Okay. Yeah, the coding train wreck. All right. Doing as a tutorial. Yeah. All right. So look at this. By the way, look at this. I now have this thing. Everyone can see this post. Sponsors only. So let's talk. This is what I wanted to talk about for a second. This is really, really a bad idea. But I'm going to go to /sponsors. So I'm in my dashboard now. So check it out. Oh, look, I'm in the same place. YouTube has this new feature called sponsorships, which is... oh, did I leave you wondering if the last tidy fixed the memory leak? Yeah. Sorry about that. Let me check that out. So it didn't, but it did, I think, because the memory leak is actually, unfortunately, there's no way to know because this inherently has a memory leak that I can't fix, but this disposing of it should work. So there's no way for me to know. All right. So here's the thing. I'm not going to go through... YouTube has this new feature called sponsorships. I'm kind of curious about it. I have a Patreon that people can subscribe to with some benefits. There's a Slack channel. There, I even will mail you stickers or books, signed books at different levels, which I'm reasonably okay at making happen eventually. I don't have any interest in doing exclusive content, so that's not something that I'm planning to do, but it does help sort of motivate me and also provide, it just helps to have the financial support. So what I'm thinking of doing, I could check the amount across one draw loop. That's a good point. What I'm thinking of doing is turning this on as an experiment and basically considering it exactly the same as this level. So if you want this $5 per month level, you can subscribe via Patreon if that's convenient to you, or you can subscribe via the sponsorships, and it's exactly the same. If you want some of this other stuff, then you would have to use Patreon. The one disadvantage to this idea that I have, one is it's sort of like this, you probably should just use one platform for the crowdfunding thing. And the other disadvantage is YouTube is really, I think, is making this a feature in particular for people who do live streaming, because what the sponsorship allows you is when you're in the live chat, you get a little icon next to your name, and you also, you get an icon next to your name. Oh, and you can use special emojis that I can unlock. So, yeah, 30% is quite a bit, but I don't know. I like to experiment with these things. I could probably turn it off if I turn it on. So I'm thinking I'm going to turn it on, and then I could turn it off. Let's see if people like the features of it and want to subscribe that way. There's no need to. Nothing's going to change in terms of how I make the content. That is remaining the same. But I can't resist. Every time I log into YouTube, they keep saying, enable this, enable this, enable this. And I'm tempted to just go ahead and enable it right now. Let me go through this. Why not? What's the worst thing that could happen? All right, get started. Right, so what I did here is I made the benefits are invitation to Coding Train Slack channel, Coding Train stickers. Continue. These are the loyalty badges, but if someone wants to make me some custom ones for Coding Train, I could do that. I added some emojis, so if you're a supporter, you'll be able to use these emojis in the chat, custom emoji. And then I'm supposed to create a sponsorships announcement video. That's what's happening now. Continue. Post the sponsors on your community tab. Continue. I'm going to do this. I'm going to turn on. Oh, they're finalizing my sponsorship setup. This could take up to, my channel is now accepting sponsors. Didn't take 20 minutes, did it? All right, so I need to go and work on the loyalty badges and the custom emojis and the custom perks. If anyone is currently a Patreon subscriber, you are welcome to, and you prefer giving YouTube your money, also, you could unsubscribe from Patreon, and you want these emojis. Nothing will change. The only differences between Patreon and YouTube sponsorship are, and I should really publish something to explain this or make a video, are you get the emojis on YouTube. Ooh, and I got a sponsor, Jake Crowley. Welcome, Jake Crowley. And look, Jake Crowley, oh yeah, this is, it's irresistible. This stuff is irresistible. So I don't, the thing is, to be honest with you, Patreon is not a service that I love. It works really well. I use it. They seem like great people trying to really make something that works. There's a lot of artists who are supported by Patreon, which is a wonderful thing. There are some issues that I have with how it works that aren't perfect for me. And it's actually a ton of effort to mail those books, and incredible. One thing that I didn't anticipate, I still send them because I want to send them, but it actually costs about, every time I mail one of those books to somebody who's international that's signed, it costs about $40 to $50. So in the end, like this, it all works out. But anyway, I'm going off the rails here. Was there another sponsor? Still, Jake Crowley is my sponsor. Oh, look at this. So I don't know. It's sort of irresistible. I'm gonna see. So I'm not canceling my Patreon. I'm not using YouTube sponsorships now instead of it. I'm trying them both. And the YouTube sponsorships. Let me make a little video here. Oh, new sponsor. See, look at this. I think one of the reasons to do this is it kind of encourages people in a way that Patreon. So let me make a quick video to release that Mathieu can edit if, which I think I can explain this now effectively. Okay. Whoops. So I think I need to sign in as somebody else in order to see the. By the way, secret channel, if you can find this channel. Wow, I have all these new sponsors. Cannabis Plays. EOD Gaming is a secret channel that might be launching soon. I'm going to switch to, oh my goodness, John Henry. I'm going to switch to that account for a second. So now, if I refresh this page, it should show the sponsor button. How come I don't see that? Oh no, no. Well, I might as well subscribe. How come I don't see the sponsor button? Does it know? What if I go to new incognito window? No. Wow, look at all these sponsors. This is nuts. Welcome, Zags. Oh my goodness. Coding Garden. By the way, you should all subscribe to the Coding Garden with CJ. But how come, where does the sponsor button show up? And where are you finding it? If I just go to here, I'll go to here. DigitalOcean's cloud computing platform was designed. Oh, I see. Giving development teams the ability to easily manage infrastructure. That's why thousands of businesses around the world. All right. Oh my goodness. Coding Garden, by the way, you should. All right. Okay, here we go. Alka, it's very nice of you to thank everybody for sponsoring. All right. Well, let me get this. Not now. So if I go to this logged in as me, I'm just curious. Oh yeah. So I could sponsor myself. That's fine. Kelly Murphy, thank you. Oh my God, this is incredible. This is blowing my, first of all, this is like my worst live stream ever, and all of these sponsors are joining. This is like crazy. I'm so touched. All right. Hello, welcome to an announcement video that YouTube told me I should make. So I turned on a feature on YouTube called YouTube Sponsorships. I actually did this during a live stream that's happening right now. You can see the chat going on here. Jake Crowley is the official first sponsor of the Coding Train. I mean, in terms of YouTube sponsorship. So this is confusing because you might be aware that I have this like Patreon that I don't really keep up with in terms of managing the website, but it is a place that people can crowdfund the Coding Train. So let me say a couple things. What do I use the funds for? I use the funds to help with expenses of the channel. And then I also earn a little income from doing this. And, it's that's what's going on here. And to be honest, it actually really motivates me to do this every week because I feel more of an obligation to the patrons and the sponsors. Now, so this is confusing. Why do I have these two different things? I don't know what I'm going to use. First of all, thank you to all these people who keep sponsoring while I'm doing this right now, which is kind of insane. It's really humbling and nice, and I'm starting to feel really guilty and confused. But this is a new feature from YouTube. It's very similar to something like Patreon. Right now, I'm keeping both of them. And I'm not planning to do any exclusive content. So all of my content will always be available. Sometimes a recording session I will live stream to patrons only, but then that always gets uploaded later. But just, if I'm trying to figure something out and I need people to watch and give me feedback. But in terms of my regular live streams and videos, I'm not planning any exclusive content. There is, however, a separate Slack channel. So if you are a sponsor, I have to figure out how I then can invite you to the Slack channel. So I'm going to figure that out. And I also will mail you stickers. This is so being a YouTube sponsor is exactly the same thing as a Patreon passenger. So if you are a Patreon subscriber and want to switch to a YouTube sponsorship, you're welcome to cancel. You can do both. I don't know why you would want to. I do still have these other rewards for like t-shirts and books and things on Patreon. I will leave those up there. So they're both things. So that's a thing now. Welcome new sponsor Barney. You get these like emojis. If somebody wants to design me some custom emojis and some custom like sponsorship icon-y thingies, you could do that. The sponsorship button is next to the emoji button. So anyway, so that's a thing now. I don't know, is this a bad idea, a good idea? Write in the comments. I feel so confused about how to do all of this appropriately and fairly, but it really, please don't feel obligated to be a sponsor. Only if you really you're able to, and it feels good for you to do that. It definitely feels good for me when you do it. I appreciate it. And so I don't know, is there a way I can thank all of the sponsors right now? Pop out chat. Welcome. Okay, so let me see. Welcome Barney. Welcome Kelly Murphy. Welcome Izumi Kushiro. Welcome Coding Garden with CJ. Hey, you should check out the Coding Garden with CJ. That's a YouTube channel that I watch. Oop, I have the hiccups. All right. By the way, I can't believe people are sponsoring me right now because I'm going to link to this live stream that I did, which was a total disaster. I attempted to recreate this Water Ripples coding challenge using the Tensorflow.js as the math engine for it, and I really it was a disaster. So thank you so much to the sponsors who are sponsoring me anyway. I'm learning Tensorflow.js in front of you, which is, I guess, a good idea, and that's that. Okay, goodbye everybody. Thank you. This was the sponsorship video. Goodbye. All right. People are asking about the fee stuff. So this is very clear to me. YouTube takes 30%. Patreon is very confusing. This is one of the issues that I have with it. In theory, the fee is just 5%, but it's very confusing. It's different based on some formula, and I can never figure it out. I just decided I don't look at it. I'm glad that Patreon exists and that I can use it. It's really kept me going with this. I should have mentioned that I have a full-time job. I'm gonna be okay. You don't need to subscribe to me, sponsor, but it is what it is. All right. All right. Okay, hold on. Let me answer some text messages from my family, which I got to deal with. I'm just sending some text to see if I need it at home. Okay. Okay. If you go to participants in the chat, you'll see that it is more than just 4 sponsors. So where do I do that? Participants. Oh. Participants. There we go. I see. So we can see all the sponsors here. All right, that's cool. Close that. Back. I need to look at all the tools here. Welcome, Bruno. All these people are sponsoring. I feel like I got to do a coding challenge to thank all these sponsors and also to have something to release next week. So what I was thinking, I'm going to close that right now. So let's go to, close this. Go to here, and let's try this one. Let me just look at this real quick. Okay, this sprinkling a few pixels. Smooth the image, cooling. Uh-oh. Is this going to get complicated? Cooling map. Uh-oh. Cooling map. Where's the cooling map? I just want to look over this and see how. What is the cooling map? Oh, I see. Cover it with some smooth pattern. Sprinkle a few thousand pixels on it. Oh, look at that. Oh, you just have this cooling map. That's fascinating. Oh, wow. I think I can do this. Yeah, this is no big deal. Read the pixel from the cooling map. P equals, add all those together, divide by 4. P equals P minus C. And then if P is less than 0, cap it, and then write the pixel. All right. All right, we're going to do this. I can't believe how many sponsors there are. So sponsor is an automated every month thing. I should have said that. Oh well. I should have said that. All right. I haven't gotten any message back one way or the other. All right, we're going to do this. We're going to make this happen. Yeah, that's a good question. If I could make people who are Patreon subscribers mods, or something. Hold on a sec. Yeah, I guess people are so used to Twitch. Okay, saying it's like Patreon and stuff. All right. I think I'm going to start from my water ripples one. Right? Okay, here we go, everybody. Welcome to sponsor Ernest G. Wilson. Okay. We're going to attempt a coding challenge here. All right. Drink some water. All right. I'm going to cycle the camera. Okay. All right, everybody. I'm excited. I'm going to do something that's going to be some coding. It's going to be cool. It's going to be great. I should write the water stuff as a shader, obviously. So I need to do some tutorials on shaders. Somebody file that as a Rainbow Topics. It's probably there already. Shaders, and these should be what I start with. Okay, hello. I am very excited for this coding challenge. This coding challenge is dedicated to all the new YouTube sponsors. I don't know, in the future when someone's watching this video, YouTube won't even exist or sponsors, but it just happened today and all these people are sponsoring like Wow Tomika. Thank you. Okay, what am I going to do in this coding challenge? So this was my previous coding challenge, the Water Ripples coding challenge. I made some fixes to it, by the way. Had some errors in the code. You can find it on GitHub. And this is just showing you the water ripples where I'm placing them randomly instead of moving the mouse around. And I didn't realize this. You can see this is called fire ripples because I've already set myself up. I was not aware of this. But Hugo Elias, there was another algorithm, a fire algorithm. And this is explained in great detail here. And so I'm not going to read the whole thing over. I encourage you to read it over. I'm just going to try to implement it. But what's really cool about this, just look at it really quickly, is it works if you create this thing called a cooling map. So I'm going to create a cooling map, I guess like this, that's just kind of noisy and grayscale-y and smooth. But you can make shapes and patterns or use an image. I think this is going to spawn a lot of creative ideas. So let's get started making this. So I'm actually going to just start with my code base from before because it has most of the same things that I need. And so if we start here, the flames can be made to start anywhere on the screen by simply sprinkling a few pixels. Most implementations had the flame source at the bottom of the screen. By the way, where does this algorithm come from originally? I don't know. I'll have to read this page over. I got to do this coding thing. Okay. So let's go here. So first thing I want to do is I'm just going to kind of get rid of the swapping algorithm, and I think I'm gonna just get rid of this, and I'm gonna just have one array, which is actually, here's the thing. I think I can just use the pixels itself. It doesn't look like. Oh, this is the smoothing. Yeah. So I'm looking at this. Yeah, but I need a current index. I need a buffer. So, but I think this might actually make more sense for me to do with image buffers. So rather than have these two-dimensional arrays, let's try something. I'm just getting rid of everything. Well, this is a nice idea. Let's do this. So much for starting with that code. All right, what I'm going to do is I'm going to create a p image. I'm going to just call it buffer1, and I'm going to say buffer2, and buffer1 is going to be an image that's the same size as the window, and it's an RGB image. Buffer2 is the same thing. And then just what I just want to do, I just want to put a bunch of pixels at the bottom that are white. So I want to say int x equals 0, x is less than buffer1 dot width, x plus plus. I'm going to say buffer1 dot pixels. And so one thing that I really need, I have a bunch of image processing videos about this, is I always need, if I have an x and a y coordinate, I need to find the location in this array. And the formula for that is int index equals x plus y times width. In this case, the y is the last row. So y equals buffer1.height minus 1. And you know what? The width and height are going to be the same for everything, so I can just use the global variable. Whoops. So this is the y. And so now buffer1.pixels y index equals color 255. Okay. So let's look now, and I'm going to say buffer1 update pixels. This is just how I'm getting things started in setup. Buffer1 load pixels. And then I'm going to say buffer1, I'm going to draw that image. Image buffer100. So, and let's actually do, I kind of want to do this well, let me just run this. So yeah, you should see, it's hard to see. If I made it red, that would make it easier. Like, let's make it red. You can see that there's a red line at the bottom. So that last row of pixels is full. So this is my starting point. So now what I want to do is I need to apply this smoothing step. There are a few ways to do this depending on exactly how you want to smooth the image. So I could probably do all sorts of fancy smoothing algorithms and Gaussian blur and all that, but this is a nice way of just applying a convolution, right? A little matrix, adding up the pixels and its neighbors and dividing by 4. So I'm going to say, and I'm going to use buffer2 for that. So buffer2 equals, no. I need to loop through all the pixels. Let me give myself some space down here. So I'm going to now have an algorithm that goes through all the x's. And it goes through all the y's. And I'm going to skip the edges. Which I might need to be more thoughtful about this later. And now what I'm going to say is, okay, so sorry, I got distracted for a second. Put time out. I'm going to have Mattia edit that distraction out for a second. Okay, so now what I need to do is let me get the color. I'm going to get the color from buffer1 pixels at an index, and that index is the same as this formula. So that is now the color. So then, oh, actually don't need to. I need to get all the neighbors. So this is going to be a very awkward way of doing it, but I'm going to do it this way anyway. I could do another loop inside here, but I'm going to do this really manually. And then so y plus 1, y minus 1, and let me put the print, just to be consistent. This is totally just my own, like wanting to be consistent here. So look, these are all of the neighbors. X plus 1, x minus 1, y plus 1. Not all of the neighbors. All of the neighbors, only the two neighbors to the right and left and the two neighbors to the top and bottom. I'm not doing the corners. So this is really simple. And so now I need to get all of the colors. And again, I could do this with, like, apply a convolution in a more thoughtful and creative way, but I'm just going to do it this way. And now what I need to do is I want to get a new color, which is equal to the brightness of C. I'm doing everything in grayscale right now. So I'm going to add up all of these. Oops, plus C3 plus C4. I'm going to add them all up together. Then I am going to, let me see, I'm going to say buffer2 pixels, and I do want that index. The regular index, we'll call that index 0, will just be x plus y times width. That index 0 is a color with the new value divided by 4. Or I think I might like to say multiply by 0.25. So I've now implemented this part of the algorithm, right? And I think I need to put it in a separate buffer because I don't want to overwrite the image that I'm using now, right? And then continue to use those pixels. So everything will get all messed up. So after that's done, I should be able to say buffer2 update pixels. And I don't need to draw this here. I need to load the pixels of both of them because I'm working with both buffers. And then I need to swap them. Swap. So I need to say p image temp equals buffer1. Buffer1 can become buffer2, and buffer2 can now be what was buffer1, which is stored in temp. So now if I run this, we should see it's going to it slowly blur away. What if I continue to always add a line? So let's write this a function let's write a function called fire, which what it does is in buffer1 it adds a row of red. Oh, and let me actually just make it white because I'm not dealing with a color yet. And let's actually call that at the beginning of draw. So let's do that over. Let's always reset the bottom one down to red. All right, what am I doing wrong here? Oh, no, that should be fine. What did I get wrong here? I expected to at least see something happening, like the color spreading up. Oh, convection. I'm not doing convection. Uh-oh. Any programmer I am not worth my salt. Oh, I forgot to draw the... Oh, I'm back. I forgot to draw the image. I forgot this whole time. I forgot to draw image. So let me draw buffer 2. Yeah, this is what I expected. We're seeing this sort of like blurring of the pixels moving up. Okay, there we go. So we can see that that's actually happening. I really would like to do this with the RGB values, but that's going to add too much to this right now, so I'm not going to worry about that. Okay, so now, so this is the heat spread. Cooling is simple and involves subtracting a small amount from every pixel. The exact amount depends on how quickly you want the fire to cool. Well, let's say I don't want it to cool at all. Let's skip the cooling for a second. Let's go to convection. Scrolls the image up by a pixel or two. So where is copy buffer 2 to the screen, copy buffer 2 to buffer 1, scroll cooling map up 1 pixel. All right, so let's see. Smoothing and convection into 1. You are indeed correct. Any programmer worth their salt should see that. I am not worth my salt. I did not see it, so that is where I'm going to leave it. What? What? That's not very helpful. What I want to explain is how to make the fire look really good. And incidentally, in this next method, okay, uneven cool. All right, so I'm gonna let's create the cooling map. You don't swap. You copy buffer 1, 2 to buffer 1. Yeah, I think swapping is fine because I'm really overwriting buffer 2 completely. So this way I'm saving memory. Sorry, hold on. I have to take a break here for a second. I don't need to swap, but I might as well because, oh, wait a sec. Let me think about this. Yeah, buffer 1 gets buffer 2. Yeah, I'm just overwriting, so yeah. I don't need, okay. Rather than recreate, rather than copy everything, I can just swap them. Hold on. I'm thinking here, what do I want to do? Just looking at this. Oh, write it to just y minus 1. Oh, of course. Okay, I see. Okay. Yeah. Yep. Okay. All right. Okay, so let's look down here. And aha. So this is actually where that convection is happening, right? I could actually just write the pixel to 1 row higher, and that's what's going to move it up. Now, I'm not adding the cooling yet. So I've got this here, but really I just need to like write it to scroll it up, I just need to like change this index 0 to this one should actually be y minus 1. So in this case, it's really the same as index 4, right? That's the same as index 4, but why not have it as a different variable? So now if we run this, we can see, there we go. Look, the fire is burning. Now, interestingly, I expected it to overwhelm everything. Right? Because I don't have the cooling in there. What am I doing wrong here? Brightness, 1, 2, 3, 4. Let's just check this. 1, 2, 3, 4. 1 minus 1, 1. This is actually no point in doing this in draw because I'm never actually iterating the bottom pixels. Oh, you know what the problem is? No, actually, I do need to do that because I'm swapping. No, buffer 2 never gets. So actually, if I want to be sort of thoughtful about this, I should just always have in both of them right? Because I'm swapping the memory back and forth. And so like the bottom should always just be a row of white pixels. And then I need to make sure I set that up at the beginning. Same thing. So what? I guess maybe I should do two rows of white pixels. So let's do this twice, just to sort of test this idea out. There we go. This is more like what I was expecting. Okay. So there we go. So this looks more, I just didn't really give myself enough white pixels at the bottom. So now this is just filling this up. I'm not seeing any fire. So let me be a bit more thoughtful about this. So I'm going to actually give this a set of rows. And I'm going to say, I'm going to have another. I'm going to use I and J here. Actually, I'm just going to use J as the second one. J equals 0. J is less than rows. J plus plus. And then Y is equal to height minus J. And I think I should be able to get away with just putting it in buffer 1. So I'm always going to add some white pixels to buffer 1. So I'm going to say fire 2. Let's look at this. Y equals height. Oh, this should be height minus J plus 1. All right, there we go. Okay, so that's the fire growing up from the bottom with setting 2 rows. And now if I want to set 5 rows to white to have more fire, you can see it's sort of mostly the same effect. 50, but you can see, that's just how much white I'm putting there on the bottom. All right, so this is the fire burning. Now, the exciting part is coming now. What I need to actually do is this cooling. I need to create a cooling map. Now, does this look like anything familiar to you? I mean, I could make something in Photoshop, I could design a shape, I could have RGB, there's so much I could do. But this looks like a Perlin noise field to me. So let's quickly make a Perlin noise field. And in fact, I could write the code for this, but I've done this before. Perlin noise 2D Schiffman processing. If I just go, okay, wait, noise 2D, this code makes this kind of pattern. And I have videos about why this works and how this works. You can go to my Perlin noise tutorial. But what I'm actually going to do is I'm just going to grab this code right here. I'm going to close that page. I'm going to close this. I'm going to go back to processing, and I'm going to make another P image called cooling. And I'm going to write a function called cool. And I'm going to say, I'm going to call cool in setup. I'm going to paste this code. Oops, shoot. Actually, I don't know why I went to the website when I could just go under processing examples. And I can go find it in topics. Maybe it's under math. How come I don't know where this is? Oh, basics. Maybe it's under basics, math, noise 2D. There we go. So I'm going to grab this code, all this code, right right here. Let's do this again. Mathieu, thank you for editing for me. Okay. Let's just go back. Forget about, all right. Let me find in examples. Let me just find this in examples. Here we go. It's actually under basics. Hold on, let me do this one more time. A better place, I'm just going to grab the code from processing examples. I'm going to go to File, Examples, under Basics, under Math. Look at this, Noise 2D. And now I'm going to grab all of this. And I'm going to put this into the cool function. But I want this to all be operating under cooling. So cooling is another image. Look at this. It has the same number. It has this. Isn't that a beautiful thing? It has the same number of characters as buffer 1 and buffer 2. So it's another one of these images. Then the cool function, I'm going to say cooling.loadPixels. I'm going to forget about noise detail and just let it be the default settings. I do need an increment variable. I don't know how I lost that. Let's make that point. What was it in the example? Oh, I already closed it. Open recent maybe? Yeah, there we go. Oh, 0.02. Let's use that. 0.02. And there we go. Now I'm just going to say cooling.pixels, cooling.updatePixels. Let's comment out drawing the actual buffer, and let's just draw cooling now. So let's look at our cooling map. There we go. So that's the cooling map. There it is over there. And I could play around with this by changing the increment value or blurring it or changing noise detail. I'm just sort of curious. Let's make this 0.1. But so good enough, right? So I'm going to leave that as my cooling map. Then I'm going to switch to showing buffer 2. And now I just have one more thing I need to add. In here, what I need to do is subtract the pixel from the cooling map. So all I have to do here is now go and say, all right, color C5 equals cooling dot pixels. Here we go. So actually, I really do want index 0 because I want to, right, when subtracting it from the cooling map is actually at xy, right? This xy minus 1 is just for sliding everything up. So index 0 should actually be this. And then secretly, I'm going to use index 4 here. And then here, I'm going to use index 0. And then I can say, and we could call this P, right? Why not? And then P equals P minus C. Oh, no. P equals, sorry, new C is that. This is C5. Now new C equals P minus C. So that is new C minus the brightness that's in C5. Now my naming here is horrible. I think I should maybe when I post this code, I might rename a bunch of these variables to make it more clear. But now we should hopefully see some fiery looking stuff. All right, hold on. Let's just do 5. It's kind of, the sliding seems to not be happening the way I had imagined. Yeah, let's see here. So this would be interesting to randomize the bottom, as was being suggested. Yeah, but what's going on? I think something with my swapping is off. Your cooling is too high. Yeah, okay. Hold on, let me go back. That's probably it. So it looked like it did something there, but someone in the chat just said your cooling is too high, which is probably the case. So let me look at how I'm making this, and let me just make these much less bright. Yeah, but why? Oh, you know what? I think it's fixed. So it is like fiery, but it's not. It's fixed because I'm only ever adding the exact same amount of kind of like white to the bottom every time. And it might actually, I probably want to add fire more in a more kind of random way. It's fixed also because I'm swapping. I shouldn't be swapping. Okay, hold on. The swapping always gets me. Yeah, it's not moving in time. Oh, right. Oh, of course. I don't want to swap. I want to copy buffer 2 to the screen and copy buffer 2 to buffer 1. So what I actually want to say here is just say, this is me copying it to the screen, and then say buffer1 equals buffer2.get. That's the same thing. I could regenerate the cooling. You want the clouds to have black gaps. So I see, probably using Perlin noise was bad. Yeah, so the swapping is fine. It's unnecessary, but it's fine. Ooh. Whoops, what did I just comment out? Whoops. Oh, whoops. Okay. Perlin noise was a nice idea. You know what the problem is? The problem is so Perlin noise was a nice idea. The problem is Perlin noise, even with me ramping it down to 100, you need to have some black gaps. Like I need just much, much less white in the picture. So I think what I'm going to do is I'm going to do something like this. And then I'm going to say if n is less than like 0.4, just set n equal to 0. So, and then maybe I should make my cooling map. This I thought would work much better. Like this is now the cooling map. Whoops. Actually, you know what would be useful is for me to, say 1200 by 400 and have width equals 600 and just keep track of these in separate variables. Because then if I do that, I can look at them both. Whoops. Something went wrong. Oops. There we go. So I can look at the cooling map next to the fire. I need to scroll the cooling map. I need to look at the chat. It's cooling map by a pixel. Oh. Oh! Look what the train just brought in. More instructions about the algorithm that I didn't bother to read. Scroll the cooling map up 1 pixel. Guess what? I could do you even better. Because it's Perlin noise, oh boy, this is exciting. Because it's Perlin noise, I can actually have y off. I'm going to call this like y start equals 0.0. The y offset is going to start at y start, and then y start is always going to also go up by increment. And so now, if I call cool in draw, we should see this scroll. That looks sort of more, this is kind of crazy what I'm doing. Okay, so a couple things now. Let's see if setting the Perlin noise back to something much brighter makes sense. And maybe I don't need to set so many rows. This looks much more like fire in an interesting way. And also, maybe I don't need to worry about this capping thing so much. I was too worried about that. It's still much too white, much too bright, right? It looks a little bit more like fire now down there. And I could try, let's make this less bright. There we go. Look at my fire effect. I also feel like it's kind of slow. Let me, where's my cooling image? Let's make this even less. There, what do we think? Kind of fiery. Now, so this looks kind of fiery. Whew. So I made this. Now, I think you could do so much more with this. First of all, like my fire algorithm, what if I just picked lots of random points? So for example, what if I just said x equals a floor random width, y equals floor random width, and then I did this. Oops. Height. And this should be w and h. So what if my fire algorithm just sets an individual pixel? Well, the thing about that, that's just 1 pixel. So what if I were to do this? What if I were to set 1,000 random pixels? Whoops. That's not good. You can see like wherever at the bottom, it's sort of, whoa, this is crazy. It's interesting what this is doing. Yeah, I think the random pixels all around here. So what if I instead did, what if I also, all right, so hold on, I have an idea. Oops, this was supposed to be in here. Yeah, the outer pixels are never updated. I have an edge problem. I definitely have an edge problem. I don't like the random pixel idea. Let's go back. Let's comment that out. So I think it really needs to be a collection of pixels. So I could probably draw a small oval of pixels. One thing that could be a good way of doing this is actually to make these graphics objects. Is it gonna like just let me do this? What if I make these all graphics objects? I don't need RGB anymore. Let me make these graphics objects. Why does load pixels fail on a graphics object? Oh, because these are now P graphics. I'm going to make these all P graphics objects and make this P graphics. You'll see why in a second. No, it still didn't work. Yeah. Huh. Draw an elephant. Yeah. P graphics, I guess, is not going to work. I thought I could call load pixels on P graphics. Do I need to say begin draw? Yes. Okay, hold on. All right, Mathieu, we're going to edit out that whole part about like setting random pixels because that's not super interesting. But I do think that, so let me just get it back to what it was. Oh. All right. So do I want to do anything more here? What I wanted to do was like drag the mouse around and add areas of pixels or click the mouse. And so let me try to do that. Okay. I think I only need to do that to one of them. Okay. All right, so there's a lot of things you could do here now with this. You could add color. You could be more clever about how you make the cooling map with shapes and things in it. Let me show you one avenue that you might not be thinking about. I think something that could be effective here is let's just think about this fire thing. I have to set pixels to white in order to start the fire. I did start the fire. We didn't start anyway. So what if though buffer 1 were not a P image, but a P graphics object? Let's just bear with me for a second. I'm going to say create. Oh, these are all going to have to be graphics objects if I'm doing this. At least buffer 1 and buffer 2. So let me make buffer 1 and buffer 2 P graphics objects, because these, and then I don't need to specify RGB, but I do need to, however, I believe say buffer 1 begin draw. So I'm about to work with the pixels, and buffer with the graphics I have to specifically say begin draw and end draw in addition to load and update pixels. And so here I think I'm going to have to say that for buffer 2 begin draw, because I'm operating on the buffer 2 pixels, buffer 2 end draw. Let's just see if this is exactly the same. And this has to say P graphics. So this should be the same. Okay, it's the same, but I've done something really exciting here. Because what I could do is I could now also say, I could add mouse dragged. And in mouse drags, I could say buffer1 begin draw, buffer1 end draw, and I could say buffer1, I could say buffer1 dot. Now I can do anything that's in the processing API. I could say fill 255, buffer1 ellipse, mouse X, mouse Y, 100, 100. And actually, let me make this mouse pressed. And let's see what happens here. So now when I click the mouse, oh wait, there we go. Look what happens. Oh, that is wild. So hold on, let me swap where these are being drawn. So now, right, anywhere I click, it kind of it starts to fire there. So let me make this mouse dragged. Oh, and let me get rid of the stroke. Buffer1, no stroke. So you can see I can kind of like seed the fire however I want. Now again, I'm just adding circles. So now the whole world is open to you. You can create your cooling map in an entirely different way. Just to remind you, this is what my cooling map looks like. But you don't have to use Perlin noise. You could actually have shapes in here. Now you could make this a P graphics thing and draw into it and blur. Somebody suggested an elephant, so you could make a sort of flaming elephant. Don't set the elephants on fire, anybody, please. Be nice, be kind to the elephants. But you should see you can start the fire on the bottom. You could add fire by drawing with the mouse. There's so many possibilities here. So I'm done with this. I want to see your creative variations. I want to see your versions that use full color RGB, and I want to see your versions that cleverly like incorporate shapes and text and other types of imagery. So make them into GIFs, tweet them, hashtag coding flames. I don't know. Dare I look, twitter.com/hashtag coding flames. All right, I think we're good. No results for coding flames. So code your flames and enjoy. All right. I'll see you in a future video. Thanks for watching. All right. So where do I want to leave this off? Let me put this back to this. Actually, I think what it would have been more interesting, by the way, I just want to put this in draw itself. If mouse pressed, pressed. So now you can see if it's there permanently, it's kind of more on fire. All right, this is the end of today. And it's 9:40 p.m. What am I doing? Oh my goodness. What happened? I don't even know what to say. I think that this can be made into a coding challenge. Let me do a nice screenshot. Thumbnail. So the thing about the thumbnails is, let me make No, not enough. After a while, it kind of starts to look like fire, though. I'm going to make a thumbnail. And I think it works best when this stuff is at the bottom, because then, and I probably should make it have color. Oh, whatever. It's got to, I didn't do it in the video. That's fine. All right, so I think this will work as a thumbnail, because then the coding challenge text can go up here. Okay, something there will work. All right. Sort of more smoky than fiery. So I'm encouraging you. Thank you to everybody who sponsored the channel during this live stream. That's wonderful. That was really exciting and nice. And yeah. I should do the damping thing instead of just reducing the whole value like the current code does. What's that? Oh, you mean I should this. What does that do? All right, I don't understand. You'll submit a community contribution pull request. Oh, I see. Do this, and then scale it by 255. Oh my goodness, that is way better. I see. Okay. Oh, look at that. All right, let's make some new thumbnails. Oops. Hold on, I gotta get my thumbnail going. I don't know. It was better for a second ago. Hold on, let's dampen it more. I could use the power function. I see. So there's so much. This is interesting. Okay, let's say power n. You know, I should really do a 3D noise too. Why n to the third power? Let's do this. Probably not going to make that much of a difference with the thumbnail. Okay. What if the other thing would be interesting would be to do this. Is this going to just be weird or will it be interesting? No, that's just weird. Yeah, it doesn't make that much of a difference because it's just, yeah. Okay. I think the thumbnails were fine. I'm obsessed. Okay, I gotta go. Thank you everybody for watching. Make it faster. You know what? What's actually? I am sort of curious. does appear to be running quite slow. Oh yeah. I think it's because I'm computing the noise every frame. There's lots of ways this could get optimized, but I'm not going to worry about that now. All right. So decrease P by constant T. All right. Thank you, everybody. Oh, yeah, the scroll could go faster, that's for sure. I will see you all. I'm going to be live streaming the ITP show, which is my students' end of semester show, on Tuesday. And I don't know if there'll be another live stream next week. I will be coming back to I feel like I need a break from all of this stuff because of how much I kind of messed it up. So I'm going to go. I would like to, I didn't even eat dinner. Totally lost my mind here. I do want to erase all this. Sometimes when I leave the stuff up here, it's very hard to erase. And I'm going to erase this also. And I wonder what happened with that poll, by the way. Let's just look at it for a second. I'm in the wrong screen. No, hold on. Switch account. Oh, EOD Gaming now has 34 subscribers. Oh, look, I see the buttons here. What happens if I click that? Interesting. Community. Oh, all right. I kind of like this feedback. That's nice feedback. Yeah. By the way, there's not very many people watching right now, but are people aware of Video grep? Video grep is a project by Sam Levine, who's a researcher here at ITP, and it allows you to make like supercuts and do all sorts of crazy stuff. I'm curious if anybody wants to try Video grep on my entire YouTube catalog and make some weird supercuts. I would be curious about that. My voice is gone. All right. So, I don't know. I can't believe the batteries lasted on this microphone. It's still got 2 bars. I thought that was going to go away for sure. Okay, so I'm sorry. I didn't realize that there were 500 people watching. Most of those people are not actually watching. It's just they left it on their computer. They've walked away. It's almost 10 p.m. It's going to be dark outside. I have to get home. The subway's even still running. It's like way past my bedtime. I didn't eat any dinner. And I basically descended into madness trying to make water ripples in Tensorflow.js. Thank you all. Thank you, Coding Garden. You're welcome for the shout out. I'm going to go. I'll see you. Yes, I'm going to go. I have a cough. Everything's going wrong. All right. I'm going to go. I am going to play the trailer and be gone. No, I'm not going to play the trailer. No one wants to watch the trailer. Make the fire red. All right. I'm going to mute this microphone. The stream's going to be shut
Let's find something we want to make, some crazy idea. We'll figure out what it takes to make that dream appear. We'll try to understand now as we ride along again. Now hop on the coding train, coding train, coding train. Come along and join us as we light it up in code, using only our imagination as the road. Whatever you're